All right. We are done with matrices for a little while. So do know we do go back to them a little bit later, but we have a nice little break here. 5 doesn't cover them. We cover like a section in 6. It's not done in 6. Then we move into some probability stuff. It comes back in, if my memory serves me correct, chapter 9. So we have a good little break here of looking at some other things. And chapter 5 is going to lead us into eventually getting to this whole concept called linear programming and using inequalities to be able to determine potential solutions that would work within certain boundaries, and eventually will lead us to like what is the best solution, and it will be just one single solution as we move through this. So we graphed a little bit of lines in the very beginning. Did we graph lines in the very beginning? I'm trying to remember. I know we wrote equations of lines. Did we actually graph them? I'm trying to remember. So most of what we're going to work with today is going to start with graphing. So some reminders are like, if it's in y equals mx plus b form, you are going to graph the y-intercept and then move the slope to be able to get a second point. If it is in standard form, ax plus by equals c form, you're going to use your x and y intercepts where you plug in 0 for x to get y, 0 for y to get x. I feel like we did that in here. So x and y intercepts is going to be the quickest way to graph them. What's going to happen today, though, is they're not going to be equals to. What we're going to graph is we're going to graph what are called inequalities. So when we graph inequalities, there's 2 things that have to happen. The first is you have to determine if you're using a dashed or a solid line, and that is dependent upon the symbol. And then when you graph inequalities, there is also shading that happens, and that is going to be either above or below the line. So what I like to do is make just a little kind of diagram here. These are our 4 inequality symbols. We have less than, greater than, less than or equal to, greater than or equal to. When you have just a less than or a greater than, that is going to be a dashed line. If you have the equals to piece, that line underneath the symbol, then it is going to be a solid line. If your symbol is a less than, you will shade below the graph, or below the line, sorry. And if it's greater than, you're going to shade above the line. So every one of you has a piece of like paper that has 6 graphs on it. And we are going to graph the first 6 of these by hand, just so you practice, you understand all of the different things that are happening here. And then we'll move into ones on Desmos because we're going to add in some extra stipulations. All right, so this first one here, y is less than x plus 1. So that means my y-intercept is 1, and my slope is also 1, and I'm going to put it over 1 because the slope should always be written as a fraction because slope always moves 2 directions. So the number in front of the x is an invisible 1. You put it over 1. So what you're going to do is you find your y-intercept, which is at 1, and you're going to put a dot. We then move our slope up 1 and over 1 from that point, and you're going to put your second dot. Once I have 2 points, I can make my line. However, this is not a solid line because it is a less than. So this is going to be a dashed line across the coordinate plane. Now, the symbol is also less than. So what I do is I go from my y-intercept. So I always go back to my y-intercept and I determine where is above the line up here, where is below the line. So because it is less than, I'm shading below the line. This is what is going to be shaded. All right, next one. Let's just say for this one, let's solve it for y to practice something that happens here. So if we subtract 6x to both sides, negative 3y is greater than 18 minus 6x. I then have to divide everything through by negative 3. Now, there's a reason I'm doing this because I want to show you both methods, solving with the intercepts and solving with slope-intercept form. So y, when you divide negative, remember that we have to flip that sign. 18 divided by negative 3 is negative 6. And then 6 over 3, they're both negative, turns into positive. I'm going to write that as 2 over 1x, just so that I can have my slope in fraction form. So I'm going to start down here at negative 6 on the y-axis. And then from that point, I'm going to move up 2 and over 1. All right, I'm going to pause there for just a second. And let's say if I had gone back to the beginning and I just wanted to solve the y piece, drop the x, negative 3y equals 18 when y equals negative 6. That is the same point I have here. Already graphed that y-intercept negative 6. Okay, I could do the same thing with the x. 6x equals 18 when x equals 3. So it would have given me a different point, this point over here. But if I follow the slope, up 2 over 1, up 2 over 1, does it work? Yes. Now, initially, this said greater than. So I already know it's going to be a dashed line. Okay? But I cannot take the symbol as a greater than in standard form. I have to make sure I always look at what would be in front of the y, because if it is negative, it flips the sign, which we see here. So we're not actually shading above this line that we've drawn. We are actually shading below the line. Now, how would I actually know where I should shade? Well, here's an easy way to do it. The origin is 0, 0. Okay, grip. If I were to plug 0 into the original equation, it gives me 0 minus 0 is greater than 18. Is 0 bigger than 18? No. So I can't shade where this point is because that point doesn't work. So that's why I shaded the opposite direction of it. All right, we're still going to work these by hand, and then we'll do decimals for a little bit, in a little bit. All right, we have 3x plus 4y is greater than or equal to 24. All right, so if I want to solve for x, I would set 3x equal to 24. And that'll give me x equals 8. 2, 3, 4, 5, 6, 7, 8. I do the same to solve for y. So 4y equals 24. I want to divide by 4. Y is 6. So 1, 2, 3, 4, 5, 6. Once I have my 2 points, I can determine if it's solid or dashed line. Because it has the equals to piece, this one is going to be a solid line. Okay, quick way to check. Plug in the origin. 0 plus 0. Is 0 bigger than 24? No. So it can't be here. It's got to be above my line. All right, next one is y is less than 4. So when you just have y and a number, this is a horizontal line through the value of 4. Okay, because y equals 4 is up here. And if it must stay 4 and there is no slope, there's no x, there's no slope, then the only option is a horizontal line that I'm going to make dashed because it is a less than. And then if I want values that are smaller than 4, am I going to go above 4 or below 4? Below. So I'm going to shade down there. Okay, next one I do need to solve. It says 4x is greater than or equal to -9. I need to have x by itself. So I'm going to divide by 4. So x is greater than or equal to -9/4. So now in this time, all I have is an x. And -9/4, that's equivalent to -2.25, -2.25. So all I have is an x this time. Well, x is, no, let me give myself a little bit more room here so that I can plot this nicely. 1, 2, 3. All right, -2.25 on the x-axis is right here. Okay, there is no y, which means I cannot have a slanted line. Nope, that's a solid line, sorry. Make that solid because it is equals to, greater than or equal to. All right, this is the only one that doesn't have an above and below. Where are x's greater? Do I want to go to the right or to the left? To the right. And then our last one here, 3x greater than or equal to 2y. Now, we always like to solve for y. So what I'm going to do is I'm going to flip the entire thing over. So 2y, and I have to keep the symbol open to the 3x. So it was open to the 3x. It was pointing at the 2y. So flip everything over, 2y less than or equal to 3x. And then if I divide by 2, y is less than or equal to 3/2 x. So this one, the y-intercept is 0 because there is no b. There's nothing listed here. So we're going to start at the 0, the origin. Then I'm going to go up 3 and to the right 2. That's going to be a solid line. And then we want less than, so I'm going to go underneath. Questions on any of those so far? All right. This one, they are already graphed, and we have to determine what the equation is. So what I'm going to do is I'm going to find the y-intercept where it crosses nicely, and I'm going to look for another nice point, and I can see that it's crossing right there. So I know I'm going to start with y. It is a solid line, and I shaded above the line. So what symbol is that going to be? I shaded above the line, and it's solid. Greater than or equal to. All right, so I need to know the slope. So let's see, how did I do this? I went down 2, and then to the right 1, 2, 3. So down 2 over 3x. And then my y-intercept is down here at -2. I mean, you can, if you go up 2 and then you go left 3, then you're going to write 2 over -3x minus 2. So it's just a matter of if it's down, you put it, I usually put it at the top. And then if it's left, I would attach it there. It's the same number. It's -2/3, whether you put the negative on the top or the bottom. All right, 34. We can see we cross perfectly at -1 on the y and 2 on the x. So we're going to start with y. We have a dashed line shaded below. What's the symbol? Less than. All right, so my slope from left to right, I go up 1, right 2, 1/2 x. And our y-intercept is -1. So y is less than 1/2 x minus 1. So I hear Siobhan already here going, y is less than, and what number? No, you're fine. 3. All right, horizontal line through the y value of 3. It was less than because it was dashed and I shaded below. Anybody want to try 36? The vertical line, so is it going to have a y in it? No. X less than? What kind of 2? -2. Yep. All right. So now we're going to look at some word problems, which is going to add 2 additional constraints to what we're working with. It says, seed costs for a farmer are $90 per acre for corn and $70 per acre of soybean. How many acres of each crop should the farmer plant if he wants to spend no more than $11,000 on seed? So we have to translate this into an equation. $90 per acre of corn, $70 per acre of soybeans, no more than $11,000. So I'm going to let X stand for acres of corn and Y stand for acres of soybean. Then we want to take a shot at how I would write this. going to be something X plus something Y, some inequality symbol, and 11,000. 90X plus 70Y less than or equal to. So no more than means I cannot go above 11,000, but I can equal 11,000. Now, can I have negative acres? Am I going to be able to graph anywhere in a negative quadrant? No, I can't plant negative acres of corn. That doesn't work. So we don't just actually have one equation. We also have to say that X has to be greater than or equal to 0, and Y must also be greater than or equal to 0. So here is where we are going to start to move in away from one inequality towards a system of inequalities, and then we'll move towards linear programming, which talks about a max or a min or the best possible solution. So we are going to do this in Desmos. And you are going to open just the regular graphing calculator now. So no more need for matrix calculator here. Okay. You'll start with 90x plus 70y. Whoa, what the heck happened there? 90x plus 70y. To get less than or equal to, you literally type the less than symbol immediately followed by the equals to symbol. And it will put it together. 11,000. So you can see I have this lovely graph here, but I actually have not plotted all three pieces. This is shading all these negative values. So what I have to do is I'm going to open a curly bracket and I'm going to type x greater equal 0, close. And you can see how immediately it put that vertical line here right along the y and got rid of anything negative x. Now I'm going to do the exact same thing for the y's. So open a curly bracket, y greater equal 0. And you'll see everything then from there is gone. Now the only downside when you graph all of these together is I can't come over here and like click and find where it's actually crossing the graph, because when you're making these in Pearson, you're going to have to plot those 2 points and you need to know where they are. So what I do is I just go back and I say 90x plus 70y, and I just type equals 11,000 so that when I come over here, I can actually find a point. And if they're not good points, I can go here, click the gear. Oh, is it not going to let me? No. Where is the... Hold on. This one should let me add my table. Why is it not letting me add my table? Usually you can add other values. That's frustrating. Oh, there's a good point. 96, 98. So that was a nice point. And then you can find other ones along the line. You need to. I used to be able to, I really thought you just click the gear and then click table and it would give a table of different points. Yeah. Look at yours. Yeah. You forgot a 0. You have 1,100, not 11,000. Okay. That's all. So this is the graph solution. It means anything on the exact line is going to equal exactly 11,000. So that point that I found, what did I say? It was like 46.98. So that would be a potential solution. 46 acres of corn and 98 acres of soybean. Also, anything within the shaded area could be a potential. So like the point over here, 50-50. That did not graph as a point. Right? Anything inside there. 30-100 is in there. Okay? So anything on the line or within the shaded region is a potential solution that could be used. Make sense? So for now, we're just graphing and finding potential solutions. Eventually, it will lead to less potential solutions and then ultimately the best solution. All right, let's see this guy. A company uses sedans and minivans to produce custom vehicles for transporting hotel guests to and from airports. Plant A can produce 10 sedans and 8 minivans per week. Plant B can produce 8 sedans and 6 minivans per week. How many weeks should each plant operate in order to produce at least 400 sedans? So all I care about is sedans. So plant A can make 10 a week. Plant B can make 8 a week. So these extra numbers, these 8 minivans and 6 minivans, is information that is not any part of this problem. Okay, so we start with X is plant A and Y is plant B. How would we write our equation? Do we want to take a shot? An X plus 8Y. All right, at least greater than or equal to. Who said that? Miles? Nice job. So at least means at the lowest I can go is 400. So I need to go above that. Sean's like, oh, that makes sense. All right, because again, we are working with real world values. X must be greater than or equal to 0, Y greater than or equal to 0. Anytime you are working with real world, if you do not write these, that is immediately 2 points wrong. 1 point, 2 point, 3 point. Okay, any real world problem, get in the habit of writing those out. Okay, so then we go over here. Clear all of this out. All right, we had 10x, 8y greater equal 400. And then I'm going to immediately follow that with x greater equal 0, curly bracket again, y greater equal 0. And when you are doing these in Pearson, you will have to draw your initial line. You'll draw your vertical boundary line and your horizontal boundary line. And then there's a little paint bucket that you're going to fill in. So I'll show you a Pearson problem after this one. Okay, so to make this easier, 10x plus 8y equals 400. What are my, there we go. Nice values. So it gives me those perfect values that I could use. And then anything else in the shaded area. Okay. 50-50, 175. As long as it's within that shaded region, it works. All right. So let's look at one on your homework really quick, just to make sure you guys are comfortable with understanding how to graph these in their system. This one. Dun, 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 dun. 4, 5, 5, 1. So it's probably going to be the later half. I went far enough. Nope, 4, 5, 5, 5, 1. I want to graph a real world one because these are there we go. This one probably have us graph and then draw its graph. Awesome. So seed cost for a farmer, 160 for acre of corn, $60 for an acre of soybeans. Hey, does this look familiar to a problem we literally just did? So 160x plus 60y. He wants to spend no more than, so that's less than or equal to. All right, so when I go to graph, hold on, I gotta make sure I got the right numbers here. 160, 60, 4,800. No! 60, 60, no more than, it was 4,800, right? And I forgot my y. Okay, so I'm doing this just so I know I got to go to the y-axis for 80, the x-axis for 30. 80 and 30. Okay, so I'm going to enlarge. I'm going to make my line 80, 30. Now, I also have to graph my horizontal and vertical limits, or else it is not going to shade correctly just the positive square triangle. So once you graph your first line, you have to graph, just pick 2 points on the y-axis and the x-axis, x this way, y this way, so that you get those bounds so that everything stays in just the positive dimension. Then you can click save and check. Okay. Make sense? I think that's all what these next ones are going to be. Do you want to see, or is this one actually our quick quiz? So hold on. So I like to pull up this one just because I then give you the breakdown of the points. If you did not upload the one from Tuesday, please go back and finish that one because this is the end of what I have today. Today was a short day. Do you have any questions on this before I send you to do one on your own? All right. So write the inequalities. I should say inequalities. Shoot, let me edit that. And that should actually be 3 points. There's a reason. 3, 6, 10, then it makes 10 points. So much nicer. All right, so I'm going to, let me go back and edit that really quick. All right. So a candidate has budgeted $10,000 to spend on radio and television advertising. A 30-second radio ad costs $200, and the 30-second television ad costs $800. So write your inequalities that represent the situation. 3 points because there are 3 of them. Graph the solution. there should be shading in your solution, so you can use Desmos to take your screenshot. However, I would say wait to take your screenshot until you've done part 3, which is give 2 potential solutions. So once I found my solution, I typed it in as a point, 10, 45, and then it shows up on my graph within the shaded region. And then you take your screenshot, you can upload it, and then that'll work for literally all of it, as long as it shows everything, because your inequalities will be shown on that page, your solution and the shaded part. Okay? But you may need to write that end part, because it says be sure to specify how many radio and how many TV ads that is. So 10 TV ads and 5 radio ads would work. So make sure you're telling me in the end what your point stands for. All right, so finish this one, do this one, then finish. And if you didn't finish 4 or 5, finish that one as well. And then you guys are free to go after that.